Here we are at example 2 from our 2.8 set of notes. We're asked to graph each of these following functions, or these inequalities. Now, for the first one, we see that x is less than -2. Now, because we have x in just some constant, we can assume that for a second that this is x is equal to -2 to kind of help us out in terms of the graph. What we're going to do is, just like we've graphed in the past, we're going to go ahead and place a dot specifically at -2 for our x value. And since there's no y here, y can literally be anything. So you might recall that from our previous set of notes. And so you should see an up and down line going something like this. And again, we've talked about why that is in one of the previous set of notes, how it's actually a standard form of graph that's going on right here. Now, when we're looking and determining if this is in fact a solid or a dotted line, we notice that there is no bar underneath, and as a result, we're going to keep this as a dotted line. Next, we have to go ahead and test some point to see which way do we need to shade. So we're going to go ahead and test that nice magical test point 0, 0, the origin. So essentially, we are testing this point right here just to see if he's actually true or not. Well, again, x is less than -2. In other words, we're taking this x value, 0. Is that less than -2? Is 0 less than -2? Unfortunately, no, that is false. So we tried 0, 0, did not work, and as a result, any one of these other points would not work as well, which means we would have to then shade on the left side. So there is more or less our graph for our first problem. Now, looking at this next one, what we're going to do is we're actually going to break this up. We're going to look at y is larger than or equal to -1, or -1 is less than or equal to y. That means the same thing. And we're going to go ahead and just graph this one alone for right now. So because we have y is essentially equal to this -1, what we're going to do is on the y-axis, go ahead and place a dot at -1. So on our y-axis, we see a point at -1. Now, since there is no x, x can literally be anything because we don't see that x there. And as a result, we're going to have a line at -1 where x can be any value. Now, we're also going to have a solid line because we do see that bar underneath this inequality. And as a result, you should see some line doing something like this. Now, when we're talking about this thing being in terms of shading, well, if we want to shade this, we're going to go ahead and test some point. So for example, 0, 0, we see that he is above our line that we just graphed. And then basically just taking that y value, is -1 less than or equal to 0? Is that a true statement? It most certainly is. -1 is less than or equal to 0. And so we would shade then upwards. Now, alternatively, we also have this criteria where y is less than or equal to 4. So we're going to go up 4 on our y-axis, place a dot there, and since there is no x at all in this inequality, x can literally be anything. So we should see another horizontal line. Also, because there is that bar underneath, we will have a solid line there. Just like before, we're going to go ahead and test a point with this part of our inequality. So we could even go with 0, 0 again. Is 0 less than or equal to 4? Well, yeah, that's most definitely a true statement. And as a result, here was our green line. We tested 0, 0. That means that it worked. Again, it worked. And as a result, we would shade anything below that green line then. And as you can see, it looks like they're overlapping in the middle. So for our final answer, it would just be the in-between shaded regions. All right. Next, we're looking at these two separate inequalities, just like we did with the middle one. But the only difference here is that we have x and y as part of those inequalities. Before we just had y. But we're still going to break it up exactly the same way that we just saw with the second one. So for our blue, we're going to go ahead and create our box using that standard form box method. There's our x, there's our y. If 0 goes in for x, y would have to, like, essentially this would be gone. So negative 2 times what gives you negative 4? 2 does that. So we're going to go ahead and throw 2 in for our box, for our y value. And as a result of that, it creates then that xy coordinate point, 0, 2. Likewise, when y is 0, essentially this piece is gone. So negative 4 is going to be less than x. X would then have to be 4. You can kind of treat them just like an equal sign. And then that again gives us our point 4, 0. So this is pretty much helping us determine what are our x and y intercepts for these inequalities to then go ahead and graph those pretty quickly. Now, since there is no solid bar underneath this inequality, we know that we have a dotted line there. So we should see an inequality doing something like that. Just like before, we're going to go ahead and test a number to see which way to shade. So we're going to test 0, 0, which is clearly below our line. So is negative 4 less than 0 minus 2 times 0? On the right side, we still end up with 0. And as a result, is negative 4 less than 0? Yeah, it is. And as a result, we're going to go ahead and then shade towards that 0, 0. Now we're going to go ahead and take the right side. Well, again, we still create our box using our standard form method. Zero, 0 goes in the diagonal. There's our x, there's our y. If we throw in 0 for x, essentially this is gone. So negative 2 times what gives us 6? Negative 3 accomplishes that. Likewise, if 0 goes in for y, essentially this is gone. So then x would have to be 6. So we end up with then these 2 points 0, negative 3 and 6, 0. We can then go ahead and plot those. So 0, negative 3 comes out to be right here. 6, 0 is right there. Connecting these 2 points, we notice too that we have a dotted line because there's no bar underneath when we connect these 2 points. So we should see something doing this. Just like we did with the blue graph, we want to go ahead and test to see where do we need to shade for this green line. So let's test 0, 0, which again is clearly above our line. So is 0 minus 2 times 0 less than 6? On the left side, we'll just end up with 0. Is that less than 6? It most certainly is. That checks out. And as a result, we tested this point. He worked. That means all these other points would then also work. And even just from the graph, we can see where these both, the blue and the green, overlap. Well, it's in between this region. So that would be our final shaded region. And as a result, that is again example 2 from our 2.8 set of notes.